Okay.
All right, so
I have to enable the webcam.
no. Oh yeah, sure. Why not? Well, just in 1 second, perhaps.
Okay.
Let me first just say welcome everybody. This is the second time we've had we've organized under this new Tech Dives webinar series where we got together from the USGS Tech Stack Working Group and the ESIP, formerly Rants and Raves. So Ethan Davis and I are teaming up here to organize these Tech Dives webinar series. And if you are not signed up yet on the mailing list, if you go to the interoperability and technology page, there's the email list here you can join, and then pretty much the only other thing on here is the webinar series itself. So if you click on the webinar series, you get to the list of previous talks. Today's talk is here, and our next talk is going to be dive into Docker with some guys. This is like Docker from the trenches. These are guys who are actually building containers and have had a lot of experience. So it's not from the Docker team, but it's from folks who are out in the wild, actually using these containers for geosciences, and these guys are associated with IUs. But today we have Biel Frontera from SOCIB talking about Leaflet.TimeDimension, and I guess this would be a good time to. Yeah, why don't you show us? Pop your webcam if you can, so we can just see what you look like there.
So can you see me?
Yes.
Hi.
We can see you, and we see a glider in the background. Very cool.
Yes.
So yeah, go ahead.
No, it's our star facility.
Yeah, cool.
The glider pit.
So a special thanks to Biel for tuning in from Spain here at I believe it's like 9 p.m. or something, but it's still before dinner time in Spain. Right.
Yes, I will arrive on time to dinner.
Awesome. All right. So so now I'm going to make you the presenter. I guess you could probably turn your webcam off just if you want, or I guess you could also leave it on. But I'm going to switch over and let's see here and make you the presenter, and then you should be able to share your screen, I hope.
Yes. So now you can see my browser.
Yes.
Okay. So let's start. It's okay?
Yes.
Okay. So hi everybody, and greetings, as Richard said, from Mallorca. As you may know, it's a very beautiful island in the Mediterranean Sea. First of all, I would like to congratulate the ESIP Federation for this interesting initiative and of the technical talks. And I expect we can join the next talk of the series. And by the way, I would like to thank Richard for his invitation to participate in this talk. He found Leaflet.TimeDimension and he contacted us, and he decided it could be possibly to be a useful tool for you. So here I am today. Okay. As you may know, I'm going to spot some information about Leaflet.TimeDimension. I will explain which needs we wanted to solve when we start developing this plugin, with a look to the previous work, and then make a tour of this library with different examples, explaining both use cases and the underlying code. But before that, let me give you some details about SOCIB. It's a marine research infrastructure, or a coastal observatory, if you want, that goes from the near shore to the open ocean. It has two institutional partners, the Spanish central government and the Balearic Island regional government, and it was created at 2009. It's a multi-platform, as you can see in the picture, system with three major subsystems. The first observing facilities. We have feature stations as oceanographic buoys, coastal stations, weather stations, and sea level stations. We also have a glider fleet, a mid-size research vessel, profiler drifters and surface drifters, and an HF radar station. We have also the forecasting and modeling facility that has a system to represent currents, temperatures, salinity, and sea level for the Western Mediterranean Sea. We have a forecasting system for meteo tsunamis, and we also have a wave forecasting system for the Balearic Sea. And we also have a data center facility, which I belong, and we manage the data systems, and we guarantee international standards, the quality assurance, and the interoperability of the data. Here you have a screenshot of our dashboard, where you can see a summary of the current deployments, as well as the range of the current values of some of the Balearic Sea state parameters here. The data that is collected by SOCIB and the forecasting data is generally stored in ncWMS files, and it's distributed. We are using THREDDS data server as a key component of our infrastructure. It helps SOCIB to implement its data policy that follows similar open information policies from around the world. Thanks to the integration of the ncWMS with the THREDDS data server, we are able to have a web math service for graded data. Thanks to this, before developing Leaflet.TimeDimension, we could develop the lightweight for ENC viewer. This viewer that you have here, that is lightweight for ENC is an application similar to Godiva that allows the user to browse through read files by variable. I have changed here the variable of the file, or we can browse by date. It also allows the user to start time series of the chosen location, or change the styles, or perform other visualizations. I'm waiting for the time series now. Okay, it doesn't want to appear. Okay, here we have. And 2 years ago, we had a time control in this application. In that moment, we didn't found any tool to create this kind of animations, and we decided to develop a tool here. This development was only for this application, and we understand that we used this application very often, but we understand that it covers only a specific use case, and we wanted to embed map viewers in our websites, and we also needed animations for other kind of map layers, as for example GeoJSON layers, to be able to animate trajectories for our mobile platforms. So I will pause this.
Just Biel, just to make sure I understand, this is you say it's very much like Godiva?
Yes, this is a Godiva-like application.
Okay.
You can open an ncWMS file from THREDDS, and then you will be able to browse its parameters. We have some preload settings. Here you can see a satellite image, or we can see our wave forecasting data that is very similar to Godiva at the end. because we can open also ncWMS files from here. But
okay.
Okay, but this is very specific. So if we wanted to embed this in our websites, we couldn't. So we decided we have to develop something new. Okay. So before developing TimeDimension, we were showing in our website only, for example, only the last available observation of our HF radar facility, like that. Only the last observation. But now, with TimeDimension, we are able to show an animation or browse by time, and this can be embedded in another website. Or we can also, with TimeDimension, we will look further later, but we can also animate trajectories of, for example, a bunch of surface. I have here an example. You can see here a bunch of surface drifters of a campaign, and we can animate its trajectories and look at the behavior. This is only an example of moving of the animation of a GeoJSON layers. So back to the slides. So we have done the introduction, so now let's dive into the LeafletTimeDimension itself. So LeafletTimeDimension is a Leaflet.js plugin. You may know that Leaflet.js is a widely used JavaScript library to create map viewers, and it's very well documented, and it can be easily extended. So we create this plugin, and I must say that that thanks to have it published at GitHub, as you see now, we have get some contributions that are very interesting from outside our organization. You can see here the contributors, and so we can see now a very basic example of how to add TimeDimension to a leaflet map. Here you can see, first of all, in this part of the code, like we can define a map as a regular map of leaflet, but we have to add in the options two options. The first one is TimeDimension, that enables the time of the on the map, and also we have to we can also add a control, the control that we have seen before, to play or to go back or forward. Then here we have a regular definition of a WMS layer. In this case, is a layer from our threads. It's a temperature layer, and this is here we don't have nothing particular. But then we can create a TimeDimension layer that takes from the first parameter a layer, already created layer, and then we add this this layer to the map. So So this is the key of the time dimension plugin. We have regular layers, and then we create a time dimension layer with a base layer that we have to add to the map. But we can also have GeoJSON layers. In this example, the creation of the map is the same, but here we can read GeoJSON, and we create a GeoJSON layer, and then similar to the last example, we have here GeoJSON time dimension layer that is a GeoJSON layer. And I have to make some remarks about the GeoJSON, because we don't, as in the WMS, we have the concept of time, because in the get capabilities of a web service, we can retrieve the times that are available for a certain layer. In GeoJSON specification, there's nothing about time. The specification only talks about latitude, longitude, and elevation. So when we developed this, we didn't have a standard way to get the time dimension information. So you have to know that if you want to put a GeoJSON layer with this plugin, you need to have on the feature attributes, the properties, you have to have a property called time or times or core times or line string timestamps.
Biel?
Yes.
Just a quick question here. For yes. GeoJSON, are there different versions of GeoJSON? Like, is this version 1.0 or something like that? And then in a future version, you're hoping to get a standardization of how you represent time, or is it just? I'm just kind of curious. I don't know much about GeoJSON, the process of the standards group. Or do you understand what I mean?
Yes. I think I sent a message to the GeoJSON group, but I'm not sure. But I think that it would be nice to put in the next version this kind of attribute in the specification. But I don't know if they are planning to do it.
Okay, thanks.
Okay. So, but Leaflet.TimeDimension is not only for WMS and GeoJSON. The plugin is shipped with these two types of layers, but in fact, the idea is that this can be extended but for another kind of layers. Also, you can extend the GeoJSON layer. I've done several times, because it might be different the attribute where the times is stored, or it can be stored in milliseconds and not in the time you expect. For this, you need to implement 3 methods on the classes that extend time dimension. The first one is on new time loading, that layers have to receive when new time loading request have been fired, so they can prepare the next layer. Also, they have to implement isReady to tell the plugin if this layer is ready to change to the new time, and update that is called after all the layers are ready. We will see this on further examples, because we will have more than one layer, more than one time dimension layer, and we will see that these layers are synchronized. An example of this we will see later is a circle label marker. It's not shipped with the plugin, but it's in this. You can see this in the example 13. That is a marker that is changing its value with the for example, with the temperature or with the layer below. It modifies this layer with the time. And it's not only for layers. We have we can as we can change the zoom of a map. Now we can change the time. So we have several methods for the time dimension property of a map. So we can, for instance, change the time. And also, very interesting, we have developed some applications with this in mind, is to listen to time dimension events. It's this example. We are listening to the time load event that is fired when all layers have been prepared for a new time, and then the time dimension changes these layers. So here in this event, for instance, it's just an example, we are updating an HTML element with the current date. So it's interesting to know that not only we can add time dimension layers to map viewers, we can also listen about time dimension events, and so change some objects outside our map. So I think it would be more easy to explain time dimension looking at these examples. For instance, this first example, it's the interesting thing of this example is that it has 3 different layers. That when we modify the time, we are modifying the time with the time slider here. Both the 3 layers are dated at the same time. You can see here the definition of the first layer, the second layer that is a contour, and the third one that is a vector layer. And then you can see it as we define a time dimension layer for each one, and finally we add this to the map. So having in mind, yes, having in mind that is interesting to have an animation with 3 different layers, and then they respond at the same time. Okay. The second example, it's more the same. You can check here that I haven't talked about the options. We can this is commented, but we can pass to the map a list of times that we want to show at the control.
So Biel,
yes.
so you could use that, for example, to present, say you had 15-minute forecast data, but you want to just show users every hour or something like that. Is that where you would use something like that?
Yes, I can show only. I have an example of this that I want to show a specific ocean history, because there are, for example, ocean and storm and some event that it's interesting. So I can fix what time do I have to show in the viewer.
Right. Okay. Yep.
Okay, we'll see that simple. Um, this third example of the radar, it shows how the plugin has been improved thanks to contributions, because we can see here that we have some limits. We have some range limits that enables us to fix where the animation has to stop. So you are now seeing how the animation is looping between these two limits, and also there are another feature that was implemented by a contributor, that is the backward playing animation. No, okay. The fourth example is interesting because we have defined here the time interval of this visualization by a time interval. When we have to define which times we want in the time dimension, we can retrieve this from the layer itself. The WebMath service can give us the list of times from the get capabilities, or we can fix this. A way to fix is, for example, with a time interval. This is the interval, the 2 weeks and today. And we also have to give another extra parameter, that is the period. So we have here a list of times that it goes from 2 weeks from now every 5 minutes. Then the other code is the same as we comment before, that we creating a time dimension layer from a regular layer, WMS layer. This example is the same, but we have an example of use of this option of the control that fixes the time steps of each time we press the next button or the animation. You will see that this animation will go 12 months to 12 months, because in this case it is more interesting to show the temperature data of the same month of each year. So we have this this option here, the time steps option. But then we have all the same as we talked before. This is the temple I said before, that we have fixed a time interval by fixed dates, and so now we can show a specific. This is our wave forecast, and we can show a specific date for this forecast when there was a little storm here in the Balearic Islands. This example, it's the same, will pass it. This is a special example because here we have two different types of layers that are synchronized. We have the WMS layer of the radar, and we also have here GeoJSON layers of the surface drifters. So it's an example of what can be done with this plugin.
Biel,
Furthermore, yes.
I know
yes.
this. I know this is not exactly the point of your talk, but where are you getting the GeoJSON? Are you constructing those yourself, or are you getting them from some service?
Yes, I'm getting this from a RESTful API. In fact, here we have the code of this these drifters. These drifters are constructed after getting the data from our service. We are here. We have a class that extends GeoJSON, and it behaves slightly different than a regular GeoJSON, because when it's added to a map, it gets the data and then it creates the layer, the base layer. So here you have the answer of your question is here. We are getting the data from this service, this web service.
Okay. So that's that's a custom service that you built. Is that correct?
Yes, it's a custom service. Yes, we have the information in ncWMS, but we have this service that open the data of we tell the service which platform, which deployment, and then it gets the data from the ncWMS, and then it changes the data for the GeoJSON format.
Okay.
Okay.
I guess actually maybe it's the right time to point out that just like you just pointed out to me, that I didn't really have to ask you how it was done, because you have the code right there below each example, and I have to say that it is quite cool to just grab this code and install Leaflet.TimeDimension and start playing around yourself. I mean, in 5 minutes you can be experimenting with your own THREDDS server and some of these tools. So it's very cool.
Yeah, there's the idea of this web page and the temples. Yes. I don't know how we're going with time, but only 4 more examples. We have here an example that reads data from a GPS. It is using another library called Omnivore from Mapbots, and then we are creating with this data a GeoJSON layer, and so now we can animate. This is my boss that goes through the mountain chain that we have in Mallorca for a running course. So here we have this is just a proof of concept that we have seen always the control of the animation control inside the map, but we can play with the time dimension outside the map. So these buttons are playing outside the map, and also we can with buttons, or also with here we have a plot of the wind in this weather station in Calamillor, it's here in Mallorca. So I choose a day that there was a little sun, so you can see how the waves are arriving to the beach. And here you will find how to create a control different for the default one. And then go to the 12. I like the 12, this example, because it's an example of using open data from, in this case, from New York. New York is bringing, giving its data for complaints. This is noise complaints. So in this case, we can see the noise complaints with a heat map in each area of New York, and this is I think it's a good example, because here we have also how you can extend a layer, how you can create a time dimension layer. This is not nor WMS layer, nor a GeoJSON layer. It's a Hitman layer. And so, as I said before, we have to create some methods with layer, with a new class, and the main are that when time is changed, we have to implement this on new time loading method, and in this case it's retrieving the data for the time, and we'll see it when it's needed. The isReady method is telling us if the loaded time is the time that we want, and the update is changing the data from the base layer, so it's changing the data that is used for the heat map. Just a minute, and then you have to create the layer, in this case, with calling this new class we have implemented. And then this is an example I talked before, because it has another kind of layer that is a circle marker layer. Now you will notice that this label here changes when the time of the map is changed. Also, we have here that the map is responding to when we click to this plot, the map is changing its time. And also, if we play the animation, you will see as the red vertical bar line is moving, because this plot is listening to the map to the time dimension changes of the time. We talked before about the time load event. And now the last example, and then we will see some websites that with the time dimension. This last example is a GeoJSON layer that this is the simulation of a hypothetical spill, and here the thing you can notice is that This is a new class. This is we are extending here GeoJSON because we have the time in this simulation. I didn't get the time in milliseconds, so I have to multiply it. And also, I don't want to modify the GeoJSONs. Only I want to show or not the feature if it's on the time, near the time that that is on the map. But also another difference, we don't have here a time dimension, the time slider, but you can see here this bar that is growing with time. This is another example of use of the time load event. Here we are modifying the width of this element according to the time of where the time dimension is. And so here are the examples. Now we have only two points more of this presentation, and we will go to the questions. First of all, I'm very proud that Leaflet.TimeDimension has been integrated with Folium. Folium is a Python package, if you don't know, that allows to manipulate your data in Python and then visualize on a leaflet map inside, for example, inside a Jupyter notebook. Here you have an example of creating a map with a GeoJSON layer. I didn't put here the features. You can see this is the how you will see this on a notebook if you know the Python or Jupyter notebook. And this is the test that is used for the Folium to test the integration of Leaflet.TimeDimension, because they have added to Folium a kind of they have implemented plugins, and one of these plugins are the timestamped GeoJSON. And then when you add this to a Folium, you will see this this in a notebook inside. So I'm proud that they decide to put this in their library. And now three uses of Leaflet.TimeDimension. If we go to our website, we have here the website of the section of the EHF radar. Sorry, and here we have you have seen this image before with the radar information, but the difference is that we have here also information about a buoy, so we can validate at the same time the observation data of the radar and the observation data of the buoy. Here we have some examples, and as before, we can change the time using the plots. And this also we have the very similar visualization with our forecast for the wave forecast. We have here three layers with the wave height, the mean direction, and the peak direction that are synchronized, and they are synchronized as well with the information about the voice. And here we have also this this plot. And the last one is this new website of SOCIB. It's a SOCIB project that called Make Click, the Mediterranean at one click. And here we can see our forecasting model. Also we have some controls to add or remove the layers. So and we have developed some more visualizations in our new website, but it's not available now. So I think it's I think I explained all that I want to explain. So I'm waiting for your questions.
Thank you, Biel. That was fantastic. It's just so cool to have those all those examples there. Like I said, it's pretty amazing. We were able to replace this old really kind of horrific thing with Google Maps and a bunch of crazy scripts and everything with just a few of just modifying a few of your examples for our forecast model, and it worked perfectly. So anyway, I'm going to open it up to everyone else. I did mute everyone, so you have to unmute yourself. I hope you can unmute yourself if you want to ask a question. Otherwise, if somebody says, just chat me if you can't, and I can unmute everybody. But otherwise, okay. Looks like, go ahead.
Hello?
Hi.
Yeah, this is Carlos from the Monterey Bay Aquarium Research Institute. I would like to ask Bill about any comparison with OpenLayers 3. So in terms of how easy it is to deal with this kind of functionality that you have implemented in Leaflet, did you try to use OpenLayers at some point, or OpenLayers 3?
Yes, no, I haven't used OpenLayers 3. I've used the OpenLayers 2. In fact, the first application, the Lightweight for ENC2 application that I showed at the beginning, is developed using OpenLayers. So I developed that animation with OpenLayers. But in the moment that we decide to create this time dimension tool, OpenLayers 3 wasn't, it was in a beta stage, so, and I liked the way that Leaflet were exposing its API to create plugins. I created a plugin before for our, with some buttons for our feature stations section in our website. So I decided to go for the Leaflet.js. Okay. So I'm sorry I haven't tried with OpenLayers 3. I assume that they have also a lot of plugins, so you could create very similar. You can have a very similar approach, but you will have to create the plugin for that library.
Okay, thank you.
Okay. Anyone else?
Well, I have. This is Rich again. I have another question. Where are you going? Are you going in the future? Are you taking this? Are you continuing to do additional development, or Do you have is the functionality? Yep, go ahead.
No, I would like to improve the control. For example, we can deal with to select time. I have shown you an example with some time selectors, but they are outside the control. So I think the control can be improved a lot, but this can be done with something someone who might want to contribute, or by SOCIB when we have enough time. Now we are with the new website, so we are not with we have planned, but we are not going to do it in a short time.
Yeah. Somebody else have a question? I just also wanted to ask, you know, when you're looping through those frames of an animation, there's no caching that's really going on other than the browser. If the browser, I guess the browser would also cache on the second time around. Would the browser be caching the images just naturally, or are you doing something?
Yes, I'm doing something. Here we have an example here. You will notice that here when I press the play button, the time dimension plugin tries to load about for default 10 times ahead, and so it creates the layers as regular layers, but they are height, and then when all these layers are loaded, then the play. So I will load again. The play is released.
Okay.
So you have a cache method here for the for this kind of layers. You can here you have this option here, the buffer option. By default, I think that it was 10. It's not necessary to put it here, but you can put that you don't want a buffer, or you want a different number of layers to be loaded before the animation.
So if that buffer is 10 and you only have 10 frames in your animation loop, then after the first time you play, or maybe I guess after you wait for them to load,
it is managed. Yes.
Yeah, then you can increase the frame rate to 10 frames per second or something, and it should be okay.
Yes, you might change the transition time, but if you don't have, if you have more times of than your buffer, you will notice that if the network or also the WMAT server is not responding at the time that you want, you will have to stop. You'll have to wait for the buffer to be filled in again.
Yeah. Okay.
But if you have only, for instance, 10 times, and you have a buffer of 10, it will be filled, and then I assume that the browser will have these 10 layers, and it will not stop, and you will be able to loop by this animation.
Yeah. Okay, I get it. All right, Biel, we're approaching the end of the hour here, and so I just want to thank you again. That was really cool, and I just wanted to also remind folks that who joined late perhaps that our next meeting, remember we meet every Thursday, the second Thursday of the month at 3 p.m. Eastern Time, and our next talk is going to be diving into Docker. Maybe you've heard about Docker, you want to learn a little bit more, or you just want to see how it's been implemented to solve some ocean-related web service problems. So join us next time, and thanks again to Biel and to everyone for showing up. See you later.
Okay, see you, and thank you, Rich.
All right.
Bye-bye.
Bye-bye.